All right, so video 3. So let's get right after this 30, 60, 90 triangle. So it says, using the equilateral triangle, show how the lengths of the short leg, the long leg, and the hypotenuse are related, right? So it says here that we have a triangle ABC, equilateral. The altitude BD divides it into two congruent 30, 60, 90 triangles here and here. Okay, so here's what we're going to do, right? In triangle ABC, we know that all the angles are 60 degrees. All angles are 60. It is equilateral, okay? So we know that angle ABC is being bisected by that BD, right? So we know that this is 30 and 30. So that's how we get the 30, 60, 90 triangle, right? Okay. So good. So I'm going to look at this triangle on the left, ABD, okay? All right, so I'm going to be clever here, okay? All the angles are 60. All the side lengths are also the same. So I'm going to label all the sides 2s. So this is 2s, this is 2s, and then this is 2s, right? The one thing I know, and again, I want to write this down. So this altitude BD bisects this top angle, but it also bisects this bottom side. So the reason that I called this 2s was because I knew they would break this up into S and S. So I already see the relationship here between this side and this side. This is 2S and this is S, right? You see that right here? 2S and S. So the real question is, what about this third side, this BD? What is its relationship going to be? Well, we're going to use Pythagorean Theorem again. I'm going to do it in blue. I'm going to let S be A. I'm going to let X be B. I'm going to let this 2S be C. Again, I should make that C look like a C and not A. Okay, so here we go. Pythagorean Theorem. A squared plus B squared equals C squared. So we'll do S squared plus B is X squared equals, and now watch for C. I'm going to put the 2S in parentheses, 2S squared. So when you do this, you have to make sure you square both the 2 and the S, because 2S squared is really 2S times 2S. So this left side stays the same. So 2S squared plus X squared equals, but over here, S squared plus X squared equals, but over here, this is going to become 4S squared. We're going to subtract S squared on both sides, so X squared equals 3S squared, and we're going to take the square root. X is by itself. The S comes out because it's being squared, but that 3 stays in. And here's your relationship. There's your third relationship, okay? So notice that it is the side S, right? That is the important side. That is the short leg. The short leg helps connect the hypotenuse and the we call it the longer leg, okay? So you'll see that the hypotenuse, and this was just from the beginning, the hypotenuse is 2 times the short leg. Again, S is the short leg. And then to find the long leg, which was our X or our B, to find the long leg, you're going to take the short leg and multiply it by the square root of 3. And there's your two relationships that you need to know for a 30, 60, 90. Hypotenuse is 2 times the short leg. Long leg is the short leg times the square root of 3. So a little bit more difficult here because you don't have two sides that are congruent. It's not isosceles. Okay, so here's your formal introduction to the 30, 60, 90 triangle. So again, in this picture here, you will see that you have a 30, 60, 90, and you have S, the short leg. So to find this hypotenuse, you're going to double the short leg. And to find this long leg, you're going to take the short leg and multiply it by the square root of 3. This is what you have to remember. Okay? So again, the hypotenuse is 2 times the short leg. The long leg, and I'm abbreviating long, is the short leg times the square root of 3. So if you keep that stuff to memory, that's very important. And again, this is for pre-calculus, this is for ACT, right? Big time stuff here, using special right triangles. On your OST, it's actually on the reference sheet. I actually don't think the OST asks you questions involving these. I don't know why. They must not think it's very important. But again, for future mathematics, this is very, very important. We'll even talk about a little bit about this in lesson 8.2 when it comes to trigonometry in these special right triangles. All right, so let's do a couple problems here. So it says Alejandro needs to make both the horizontal and vertical supports AC and AB for the ramp. Is one 12-foot board long enough for both supports? So the question is, right, the horizontal and vertical, AC and AB, if we combine them, will it be less than or equal to 10, right, or 12? Will AC plus AB together be less than or equal to 12? Because if so, then we have enough board. Well, we need to take a look at this as a 30, 60, 90 triangle, right? In this 30, 60, 90, and I was rotated, this 30, 60, 90. So AB is the short leg, BC is the hypotenuse, and the long leg is s squared of 3. So notice here that you are given the hypotenuse. It's equal to 10. And again, let me just emphasize that this is a 30, 60, 90. So you are given that the hypotenuse is equal to 10. So we can use that hypotenuse to find the short leg. We know that the hypotenuse is 2s. That's equal to 10. If we divide this by 2, we get the value of s. S is 5. We now know that the short leg is 5. We know that this is 5 feet. And now we can use that 5 feet, and again, that's a 5, not an s. We can use this 5 feet to help find the long leg, because the long leg is going to be, so the long leg, the long leg, is going to be the short leg times. It's going to be the short leg, which was 5 times the square root of 3, right? And that's all it is. Now, we do want to estimate that, and that comes out to be about 8.666 feet. So we know that the short leg is 5 feet. We know that the long leg is around 8.66 feet. So now we're going to apply our idea. If we add those together, are we going to be less than or equal to 12? Well, unfortunately not, because 5 and 8 is at least 13. This is 13.66, which is not, slash go the other way, which is not less than or equal to 12. Therefore, he does not have enough. No. Okay, last but not least here, all right, so we have Olivia starting an origami paper crane by making the 200mm diagonal fold. What are the side lengths and area of the paper square? So if you notice here, right, this is a 45, 45, 90 triangle. If you notice here, it's a square. We should know that the square is a parallelogram, which is also a rhombus. We should know that the diagonal bisects a pair of opposite angles. Again, these are 90s, half of 90s and 45. So this is a 45, 45, 90 triangle, right? Okay, so this is S, this is S, this hypotenuse is the leg times the square root of 2, right? L square root of 2, whatever you want to call it. They use S's. So we are given the length of the hypotenuse. We are given that the length of the hypotenuse, S square root of 2, is actually 200. We need to solve this for S. All right, so to do that, we have to divide by the square root of 2. This gets the S by itself, so S equals 200 divided by the square root of 2. And now we're going to talk about how you rationalize. You would not have to do that here because I think you could round, but in future problems, right, that you might see, we cannot have square roots in the denominator. So we're going to do this thing called rationalizing. All right, so I'm going to draw an arrow. This is called rationalizing the denominator. To rationalize the denominator, we simply multiply by it. But we have to do it on top and bottom, because to keep a fraction the same, to keep it equivalent to the next fraction, you have to multiply the top and bottom by the same thing. So this becomes 200 times the square root of 2 on top. On the bottom, when you take the square root of 2 times the square root of 2, this becomes the square root of 4. But what is the square root of 4? The square root of 4 is just 2. And now we can simplify 202 200 divided by 2 is 100, and the square root of 2 just comes. That is the length of the side length. The length of the side length is 100 square root of 2 millimeters. If you want to estimate that, that's about 141.4 millimeters, whatever they want. So that's the length of the side. And now we come over here because they want the area as well. So the area of a square is side length squared. So we're going to take in parentheses the 100 square root of 2, and we're going to square it. If you leave it not rounded, you're going to get a nice number. Because what you do is you actually square the square root of 2 and you square the 100. So it's actually 10,000 times 2, which is 20,000. And that'd be millimeters squared. But again, you can just type it in a calculator and it will give it the answer too. Okay, so again, 100 times 100 squared is 10,000. The square root of 2 squared is just 2. And that's how you get the area of 20,000 millimeters squared. All right, lots of fun in this section. Again, buckle up for this topic 8 because there's a lot of problem solving, a lot of fun stuff. So good luck today.